Okay, I think
Yes.
it's recording now. Let me welcome everyone first. Hello, everyone. Thank you for being patient. We are a bit late on this session, and I'll start with Happy New Year. Happy New Year, everyone. We
Happy
wish
New
you
Year.
health, good sleep that we didn't have in our team, like Mog was saying. Good sleep, good health, good business, good family, good relationship with people, and peace around the world, hopefully. 2025, let's make it our year, guys. So that's how I wanted to start this. And Eli, the honor
Yeah.
and always the respect to you to say a few words as well, a few eloquent words.
Well, there's nothing really to say, but it's just nice for everybody to come together. Mog, thank you for giving respect, with what you've been doing and listening to Mohammed. But just want to say it's just nice for us as a community to come together and just work together. No matter where we are in the world, we're just here to share the load.
Yes, fantastic. I have a present. I only have like 2 slides to guide me on what we want to do today, and we are a bit modifying Eli because I think the last session we did was on the hardware.
Hmm.
And now actually the hardware, we really need to master it among ourselves. And I'm going to cover the why, and I'd like to have your feedback, guys, on what do you think as well. So Mog, I will just repeat because we were not recording, but you said that the mega AI data center project that the executive order that Trump signed the day before yesterday or a couple of days ago, some of the biggest centers will be near you in Texas. Is that correct? If you can say a few
Correct.
words.
Yeah, specifically in Abilene, Texas. So not too far from Austin, like the capital. And there's just a lot of some of my customers, clients, they're into providing the hardware to build the data centers. I
Oh,
was bringing that to their attention, and so they can be more strategic
Mm.
about their branding. And yeah, so it kind of it's made me think about different avenues that we can start leveraging this and taking advantage of the narrative to
yes,
promote our AI and automation practice, right? And you don't need a big data center, but you can still leverage a distributed
indeed.
ecosystem and have your own private. So having that narrative, I think this is the time right now to start proliferating that messaging. Yeah.
No, definitely. I think we have a nice momentum to position all of us ourselves at both at the business level, the narrative level, the business level, the marketing, but also the technical side. And I think it fits well. If you guys don't mind, we modified the initial agenda. We wanted to cover the tech stack analysis and the hardware, but I think it's good that we focus on the hardware and we did some additional work on the hardware. And also, I noticed that sometimes, because some of us are a bit technical, we didn't really define many terms that we need to understand as businesses and that we will need to explain to our clients as we go. So that's what I wanted to cover today. Maybe before I start that and tell the why we need to do this and how I think the decision from the US government is going to affect us in a positive way, I want to first just take a couple of minutes to introduce the new people, or at least the people who we see their faces for the first time. So let's, if you don't mind, I'm going to start with the order that is in the list of people here. Bill, how are you? I know that it's been a while. If you want to come up and just say hello, it's nice to see you again. If you're
Sure,
not in a
sure.
position,
Thanks. Happy New Year, everybody. I'm happy to be joining again, and good to hear all the progress. Sorry, I missed the last one. I just
no,
kind
no
of got
worries.
sick.
This is gonna act as a refreshment and in-depth knowledge and discussion because you're very much involved in the hardware of AI. So I think it would be very nice to have your feedback as well, Bill.
Sure, sure. Yeah, right now I'm at home, so I decided to put the camera. I kind of help
Mm.
with my kids, so.
No worries.
But
The bee
yeah,
with the
thanks.
green background looks a bit like you. Okay.
Good to
Sorry
see you guys.
for the bad joke, but thank you, Bill, for being here.
Yeah,
Uh,
the $100 bill, with the green.
it's him. I don't know if Honoré, only his note taker is here, or Honoré, are you here? No, he didn't connect. Okay, let's go. Jasmine. Jasmine, do you want to say a word? Are you comfortable to say a word?
Greetings, I'm Jasmine. Feels nice to meet everyone. I missed the last couple of meetings, but I'm so excited to be here. So excited to meet and network with everyone, and be a resource and be valuable. Use me in any way possible. And so,
No, definitely. And Jasmine, we did the video, our session, and already people are asking about you. So I think a lot of people will come your way in Florida and around. Jasmine is our master agency representative in Tampa, Florida. For those of you who didn't see the video, Jasmine is a fantastic profile, technical, commercial, business, branding, artistic, everything is the full package. Jasmine, honored to have you with us.
I'm honored for your work. Thank you. That was a nice intro. I love it.
Thanks, Jasmine.
Thank you for having me.
Pleasure. And then we have Joe. Joe, if you want to come up and say a couple of words, you're more than welcome. Okay, no worries if it's, oh, virtual assistant, VA. Okay, we have Kyle. Kyle, we had a first discussion. I don't know how comfortable you are, but maybe you want to say a couple of words of who you are, where you are, and what you do. I think you have a very interesting project in the pipeline.
Yeah, hello everybody. I'm Kyle, and I'm in Vancouver right now. And yeah, I started my company around last year, and I'm a new entrepreneur. I used to be a software engineer, working in a logistics project. And yeah, I'm happy to be here, and I'm excited to see how where Artilla is headed, and especially its integration with AI and everything. It's a very capable software, I think. And yeah,
Excellent.
I'm looking forward to see how this is headed and be part of it.
Yeah, definitely, and also for you, Kyle, because you're like a tech guy from the software engineering coming into business. So we have a lot of people here who are very well versed in business, and maybe for those initial steps, just feel free to reach out to Eli, to Zach, and anyone to leverage our network. And welcome, Kyle.
Yeah,
Welcome
thank
again.
you. Yeah, I'm still a beginner in business, and I'm still learning lots of things about it. So yeah, yeah,
Yeah,
thank you.
that's part of learning, trial, error, and using our people who already made those mistakes. I think that's one way forward. So thank you, Kyle. Matter Facture, I think we did a presentation. Mog, it's actually the first time that... No, is it the second time? Did you present yourself in the first video, Mog?
I I I don't recall. I
Yeah.
think I did,
He
but
did. He
I'm
did.
happy to. I'm happy to.
Yeah, let's
But,
just say a few words where you are and what you do, because also the geolocation of the event is happening there.
for sure, sure. My name is Mog Obahor. I'm based here in the Dallas Fort Worth area, and I've married with 3 kids, and been a technologist for over 15 years. I'm also a business owner, avid reader, and just love languages. So I've been in the automation and AI space for at least over a decade. Done a lot of work, building software, managing software teams. So really excited to add value to the community. I was really excited about what we're doing to really empower SMBs. Really, that's where my heart is.
Yeah,
How do we build, grow, and optimize so we can spend more of our time with our loved ones and our friends like you guys? Yeah, let's automate the grunt work so we can spend more time in doing higher value, stuff
definitely.
like relationship building and stuff.
And
So
fulfill our humanity better and further.
yes. So nice to meet everyone. Yeah.
Mog, pleasure to have you, honor to have you, and thank you for these words. And then I think Ryan, if you want to also tell us a few words and a contribution goes both ways. If you feel comfortable, Ryan, please feel free to.
Sure, yeah. Happy to. First off, happy to be meeting all of you. Ryan Richtrink, married with 4 kids and 1 grandbaby. That's brand new as of the last couple of months.
Wow, congrats.
Super.
Yeah, thank you. Thank you. So been really come at technology from the business side of things. I developed a business incubator probably about 17, 18 years ago. Been involved with the entrepreneurial ecosystem ever since. Love building out the use cases and solving very complicated problems using technology and data and whatnot to really unlock human flourishing is really the goal of the current project, which is what I call shared purpose economy. It's sort of the value that can be created and exchanged between employers and employees beyond just a paycheck. And when people find work they love and are good at, and vice versa, it's a win-win there. So we're building some tools and some insights and new types of data for talent matching that we really want to produce human flourishing through and help people take greater control of their own career path, and also help employers recruit for engagement and retention instead of just job requirements. So
that's super.
That's awesome.
Yeah, that's fantastic and super on time with. I think after COVID, there are many studies about staff mobility. People, they come into a company and they leave and they're not happy. So I think this is becoming even more relevant, Ryan. And we're happy if we can add a little stone into your edifice as you build it, all of us in the community. So welcome, Ryan. Thank you for
thanks
sharing.
for having me. I appreciate it.
Pleasure. I think we reached the list, and let's start, if you guys don't mind, with this decision, and I'd like to share with you guys some kind of visualization of how the future, how I see it playing, and how our team thinks that it could play. Now, just in the US, I think Trump signed a $500 billion allocation to position the US as the leading AI center. So there is a technology, but there's also the geolocation. That means that a lot of resources are going to be put on the ground, on the local people and the people working there. And like you said, Mog, I believe that when it comes top to bottom from the government, when there is such a policy about a specific technology and its development and such a level of budgeting, this is gonna, how to say in English, trickle down, and it's gonna reach the small businesses and the small entrepreneurs, and in between the big corporations, the banking system, and the small entrepreneurs, a lot of opportunities are going to be created all along this value chain. And I think there will be probably a lot of fiscal incentives, a lot of budgets for development grants in developing AI. And I would invite everyone who are in the US to be at the forefront of what is happening in terms of incentives, and let us be aware of those incentives so that we can tap into the market and provide those services as early as possible to the needs that are being created by this policy. So I don't know if it makes sense, especially for you guys who are in the US and North America. You have a better knowledge than me as a non-American. But does it make some sense?
Absolutely,
Oh,
Mohammed. Yeah, as you mentioned, the value chain, um, it's just being intentional and just looking for, opportunities to sort of add incremental value, because whatever outcome is not going to be realized just because the budget is there. You still need the right, talent, the right people, to plan, to orchestrate the whole 9 yards. So I think it's
yes.
it's going to be a big deal.
Yes, and let us position ourselves as early as possible with the right knowledge and skills. So that was one point that I wanted to share with you. And then another point, which is more of an image or a vision, is that if you guys remember when we had MS-DOS and then we had Windows 95, so those of you who are old enough, we used to have like software updates of our operating systems once every 3 years. Like there was almost no update between Windows 95 and Windows 98. And then the cycle of software revamping, accelerated and accelerated. And now today, like when you look at Mac OS or Linux, there's like incremental updates almost every month, every 2-3 months. And also last time we used to be able to create one website per year, one website per 6 months. One people in 10 could create a website, or actually one people in 1,000 could create a website, and then one people in 100, and then one people in 10. And today with all the Shopify's and so on, almost everybody can create a website. So I see the same evolution happening now with AI fine-tuning. So today, only the big corporations and the big guys, they are training models and fine-tuning them and then releasing them into the market. And then the big corporations, non-tech big corporations, they're going to start to fine-tune their own models and then deliver them in the market as a product. And then the small enterprises, MOG, they will soon be able to fine-tune their model, productize it, and give it to the market until we reach the consumer level where you and me and my cousin, who is not super IT, will be able to fine-tune his own AI model locally every month or every week. That's where we are going. Almost like now, everybody can do a WordPress website, Shopify website. Everybody in maybe 3, 4, 5 years will be fine-tuning their own customized AI models locally with their own data set to serve their own specific purpose for that AI model. So if we look at these evolutions like we had did with the operating systems and with the software, and we guys are at the beginning and the top of the chain, you can imagine how much we can benefit from it before it becomes so mainstream media, so mainstream that it will not pay so much to fine-tune an AI model, because every cousin, every auntie, every uncle would be able to fine-tune it. So that's how I see it playing. Again, I don't know if it makes sense, but at least to me, I see it playing, and I think that if we get the knowledge early enough in our groups, and if we are the early fine-tuning providers, we're going to be positioned in the market before the market saturates. If that's Eli, does that make sense from a strategic perspective? You're mute, I think, Eli.
Can you hear me?
Yes, now we hear you. Yeah.
Yeah, no, it totally makes it's how life always starts, right? It's always the way. So we position ourselves really well, especially now we have a business in a box, Mohammed. Remember?
Yes.
Yeah. So you've made our lives much easier to start things off with.
Yes, and also I wanted to use this segue of the political fiscal incentives that is being formulated, and I think it will impact the whole world, not only the US. Plus this technology development trend and how it democratizes for us to justify an extra effort, all of us, in understanding this technology and understanding the nitty-gritty of those terms. And we have to all be very AI hardware aware to be able to serve businesses and tap into this coming market. And I'll share my screen just to guide myself and share with you the update. I'll try this time. We thought maybe we can do less of Mohammed talking and more of question answers. So I'll try to give you a quick update, and then maybe we can take more time and simulate between us. How should I buy my AI hardware? This is my use case. I want to do this and this and that in 1 year, 2 years, 3 years, 5 years. What kind of hardware should I buy? Oh, I have this other use case. I'm more into lightweight, portable, robotics, edge applications. So then we can play around, play multiple role bases between us. And then at the end of this, or in a couple of days, we will share with you a BPMN, business process modeling, or like a decision matrix on how we can advise businesses about their hardware needs. That's the idea. So this was supposed to be the first slide. We've done the number
Mohammed,
one.
Why just a decision matrix? Why not we create a chatbot? That's going to answer our questions.
So no, it's perfect. So that's a good point, Mog. And also this is like a method that we want to share with you, is that we want to start with data, gathering the data and the knowledge. And then once we have the data and the knowledge, we create kind of a non-dynamic matrix, like how you call it, non-dynamic is static matrix, even if it's a Google Sheet. And then we we play around with it, we fine tune it. Once we know that this is working in Excel or Google Sheet, then we create an app or a chat, you know. So that's what we try to do, not to put the software before the data knowledge or the data structure. But definitely a chatbot, that would be the end product. That would be super cool.
Got it. Got it.
Yeah. So we start with the data, and that's what we've done with the team. We gathered as much data as possible. We crunched it, we simplified it, and we try to bring the definition so that we can have a crystallized understanding of all these terms that are thrown around in AI hardware. So the rapid introduction of new members, we've done it. The definitions, it's just a slide, the next slide. And then I will share with you the updated Google Sheet, and then we can move into the questions and answers. So let's look at the, so I'm going very raw here, just to engage the discussion, but you will hear, and you have been hearing these words, inference. And often, even me, I was confused. What is inference? What is training? What is fine-tuning of AI models? So to put it in a very simple language, when you say AI or LLM, large language model inference, it means using them, using the model. So for example, when I chat with ChatGPT and I ask it, how far is the moon from Earth? And I get that answer, I'm doing an inference. I'm inferring to the AI, and the AI will give me the answer. That's the inference. So it's not as complicated as it seems. So, but it's important because some hardwares are more specialized in doing inference better than training or fine-tuning. Some other hardware configuration are much better at training and fine-tuning than they are for inference. So that will impact how we advise hardware for us, for ourselves, and for our clients. So that's inference, one. I'm going to go through all of them, and then we can take questions and give some precisions. Training an AI model, what is the difference between training an AI model and fine-tuning an AI model? Is that training is like when you start from scratch. You need like massive, gigantic data sets, like billions and billions and billions of dataset parameters, and you need to come up with this crazy infrastructure of hardware and big data centers to come up with one model like ChatGPT 3 or ChatGPT 4. That takes enormous resources to do to train the initial model. So that's not what we are doing in our group. That's where we come and jump in, because these big guys, they already train models, and every Microsoft, OpenAI, Anthropic, they trained models, and then they release these models and they make them customizable and fine-tuning. So that's the training part. So we are more into the fine-tuning. That's where we are more able and where we have more opportunities to provide our services and create value. So fine-tuning is when you are going to customize and specialize an existing and already trained large model, and you train it on a specific data set so that fine-tuned model will perform 5 times, 10 times, 3 times better than the generic model. For example, ChatGPT may be very good at answering generic questions about financial data, like business plan and programming and financial projections. But let's say you're an auditor and you want to give a specific analysis that is audit oriented and that has some and relies on some specific data sets that you have in your career, that you know that this is how you start with the P&L and this is how you correct it and how you audit it and the documentation that you add to it. So that is a data set between the input and the output for all the thousands and thousands and thousands of clients P&L that you did. That's what we're going to use and feed into an existing AI model to make it much more performing for predicting or reformatting or correcting profit and loss documents. So that's what we call fine-tuning. And it's not so complicated, guys. We are already able as non-developers to fine-tune models. And the idea is that we will teach you and we will accompany you on how to use Artilla to scrape data sets, scrape, organize, and format data sets into the right JSON format, and then how to feed that data set to a local model, and then how to fine-tune it, and then how to package this AI model into a file that can be downloaded and added to Olama, and then used again by Artilla from the inference side. So we do both ends of the spectrum. We do fine-tuning. We fine-tune a model, we deliver it to the client, or we deliver it to the market, and then we add bots and Artilla flows that will now use those specialized models to perform even better automations that are AI powered. So that's the idea behind this approach to defining these terms. And then in the hardware also, you will you will hear more and more about the concept of sparsity. Are you guys familiar with sparsity? Anyone knows already what is sparsity? Just to test the waters.
No.
I don't personally.
Okay, excellent. So these are good concepts for us to master. So I'm going to just modify so that I can see your faces as well, guys. Here, put it this way. Is it still readable? Eli, is it still readable? Okay,
Is,
excellent.
Yeah, totally. Yeah.
So sparsity is this mathematical operation or computing operations that ignores the zeros and the spaces and the emptiness. So I'll give you a human example. So for example, if I want to tell to Eli, hello Eli, how are you? In hello Eli, how are you? There are 3 or 4 spaces. So if you don't use sparsity as a technique, you have to code for the space. So if I don't use sparsity, I need to say hello space Eli space how space r space you. So I compute more data, I do more operations, and I take more time and more resources to say the same thing. That's sparsity. So the same with AI models. If they get a hardware feature that allows them to skip the zeros, they can process data faster, they can reply faster, they can ingest faster, and they can save that computing power of dealing with nothingness, and put it in dealing with actual presence of data. That's the concept of sparsity. Is that human enough language, Eli? I rely on you as a dictionary.
No. You've made it clear. Cool.
Excellent. So
I've learned something.
that's sparsity. And you know that we are in a binary world. The digital world is binary. It's a lot of zeros and a lot of ones. So zeros are actually very important. Sometimes coding the zeros or not coding the zeros makes a huge difference. But in human endeavor, we almost always discount the zeros. So that's what we need to understand at the hardware level, and it has an implication on the performance level. I will show you in the Google Sheet what it means at the performance level. Then you will see a lot of this acronym. Yeah, please, Mog.
Oh, yeah, sorry, just for the benefit of, yeah, so I was going to ask a question since you said this was going to be conversational, right? So just
Yes,
making
of
sure.
course. Yes.
So what are the benefits of sparsity? Yeah.
Yes. So sorry, I'm going to grab a bit of water. So sparsity is a combination of a hardware feature and a software framework feature. Basically, the end result of sparsity is using the same amount of CUDA, tensor cores, RAM, and computing power. I can process much more data faster because I don't have to deal with the zeros. So if, let's say, in a string of data, there is a total of 100 characters, inside there are 30, 50 zeros. If I can skip the zeros, I only need to deal with 50 instead of 100. Therefore, I can output twice more data. Mog. So my computing performance is going to double or at least be multiplied by 1.5, 1.8. That's how it translates into the computing aspects.
Got it. So basically, sparsity would help to kind of reduce the storage requirements, and
Yes.
Also helps computationally with the time.
Every operations that is done by the AI model, the GPU or the CPU, is going to benefit from having to ignore and avoid processing emptiness.
So fewer features and parameters. So just ignore, those empty things essentially.
Yes.
Okay.
Yeah. Essentially, it's like now the technology, both the hardware and the software, is able to recognize and ignore the zeros. When you don't have sparsity, they deal with the zero as if it was a character, as if it was valuable data.
Got it. I wanted to put it in layman's terms for
Yeah,
my
no,
brain
thank
to
you.
understand. So just reduce the computational, overhead and memory usage overall to be able to, compute faster and, get to better efficiency.
Exactly, and use less electricity for the same data output.
Got it.
Yeah.
Okay.
I think Jasmine wanted to say something also. I think
Yeah.
she put
Who?
her hand up. Jasmine?
Yes, Jasmine, please.
Yes, Eli, thank you. Mog hit it on the head, nail on the head with the hammer as far as translating that, right? I just want to say that businesses care about that, right? Like when you're talking to your clients, they care about the amount of data that they're using, right? They already have so much data in place. And so when you're that's a great talking point, basically, is just what I wanted to say. When you can, if you can translate that to them and speak to them about that, they will care. It matters.
Yeah, definitely. And also when you choose the hardware and you tell them this is why we're going to choose this card because it has sparsity, then it justifies why you're saying that, Jasmine, and it translates into a lot of savings. I think Ryan, Jasmine, you want to add something? And then we can go to Ryan.
Oh no, I'm sorry. I meant to hit the mute button.
Okay, no problem. Thank you, Jasmine. Guys, please do not be shy. Interactive knowledge, and also most of the time you guys have better knowledge than me and the team on certain aspects. So let's share it. Ryan, to you, please.
So my question, just to clarify, I guess in layman's terms, it sounds to me like it's like defragmenting your hard drive to open up space.
That's
but
a
at
good
the data,
analogy.
at the data layer, right?
So defragmenting was a sparsity technology. So sparsity is a concept in data that we find in many software and many hardware. But you're right. What we used to have when we defragment the hard disks, it was that removing the burden of having empty space between chunks of data.
And so is that done? I'm curious how it's actually done. Is that done in advance? Is that like compressing? So like where does it remove the
On the fly. On the fly, when it
on
loads the data in the GPU RAM. So usually when the hardware will, so when we download an AI model, it will sit physically as a file in our hard disk, in our SSD disk. But when we kick off the AI, when we kick off Olama or any other interface, it will load the whole AI model into the virtual RAM of the graphic card. The model will stay there, and that's where all the operations are happening. And that's where sparsity is much more important because it loads everything. So if we can remove so much of those empty space, we can load bigger models and we can process and we can interact with the models much faster.
That's
But
great. Thank you.
there are much more to
Appreciate
this, but
it.
I'm just sharing like at least the, let's call it the top of the iceberg level for us to understand at least the concept side of it that will impact the business decisions. Okay, so sparsity is a very interesting concept, and actually for me it's a spiritual concept, Eli, as you talked with Mog. Sometimes there is more knowledge in the absence of knowledge, or there is more data in the absence of data. So the absence of data is a data source itself in the realm of human knowledge. And
Can I just say quickly, Ryan?
yes, please.
When you was breaking it down, talking about defragmentation, my God, you made me feel old. It takes me back to the late 80s and the early 90s. I totally understand that concept because I used to defrag all the time, and I thought, oh my God. And you've made it sound simple without a doubt, but you made me feel old. Thank you, Ryan.
Yeah, that's the generational connection. Thank you,
Exactly.
Ryan.
Yeah, but it made
Yeah.
sense. Totally
Sorry
clear.
about that.
No, don't be sorry. Honestly, I just found it funny. So I thought I'm a person that just says it straight. But thank you anyway. But it made sense. Thank you.
Excellent. Let's move on now. I see that sparsity is an interesting subject, and I'm surprised that so few people know about it. So it's good that we know about it so that we can explain. Let's now move to the next acronym that comes like is thrown all around in the world of AI and hardware. It's what we call the TOPS and TFLOPS. So this is in the language of supercomputing and computer science. Is usually when you have a T and then OPS, it's about tera operations per second. Tera is 1 trillion. So it's huge. This is very hard for us to comprehend because we're not used to these numbers. But basically what a top is, one TOPS is, for example, Eli, if I do this in my head, if I do 2 plus 2 equal 4, that's one operation. So Mohammed as a human, even if I drink a lot of Red Bull and maybe use some Moroccan hashish to sustain the creativity, maybe I can sustain 1 operation per second for 1 minute before I go mad. You know, how many operations I can do. And that's where also, Eli, I wanted to link with you. We as, let's say, normal, but I don't mean positive or negative judgment on normal people, but when your mind is formatted in, let's say, the socially accepted norms, we barely process 1 operation per second. But autistic kids and autistic people, they can process 2, 3, 4, 5, 10,
Yeah,
10 ops.
definitely.
So that's where you understand that some of us, they are closer to the way that AI works than human works, because they will be able to do multiple operations of different natures in their head in one go. But that's the concept of tops and flops, is that it's a gigantic number of mathematical operations per second. So we're talking big volumes here. And I will explain the difference between the tops and the T-flops, because this is a little bit subtle and we confuse them a lot. And the hardwares, they differ a lot between if they're good at tops or good at T-flops. And I will explain what is the end result. So a normal, let's call it a normal tops, a normal operation is what, like I said, Eli and Tim, I said 2 plus 2 equal 4. Or if I say 2 multiplied by 5 equal 10. I'm dealing with integer numbers. How you say, Mog? Integer in English?
Integer.
Integer.
Yeah.
So
Yeah.
when you do tops, you're dealing with integer, full digits or full numbers. So I don't have to deal with fractions, decimals. It's a full number that is operated with another full number, and it gives me a full number as a result. This is one way of calculation that some hardware are very good at it, some hardware are less good at it, dealing with full numbers. So that's what we call tops. This is the kind of mathematical operations. T-flops, and it adds F and L. F and L is for floating points. So floating points is the decimals. So for example, I was giving you the example that a tops operation in my example was 2 multiplied by 5 equal 10. A T-flop operation that gives 10 would be 1.5 multiplied by 8, because then I have to break it down into multi-steps operations and then joint and verify my result. I will do 1 multiplied by 8 equal 8, 0.5, which is a quarter of 8, will give me 2. I do 8 plus 2 equal 10, but you see how much energy I spent to reach the same result, because I'm dealing with floating points. The same goes with our hardware. Our hardware, to deal with floating point operations, it requires much more resources to calculate, and it requires much more steps in the transformation of data, and it requires a higher level of precisions, because if you mess up 1 decimal, you can mess up a big chunk of the result at the end. So the hardware will be different when it's for floating operations. It will require a different level of precisions. I'll give you an example. When you are calculating the circumference of a circle and you use pi, you can go like infinite decimals in pi. Yeah? And if, let's say, I'm just drawing a circle on my table, maybe I just use 2 decimal with pi and I get roughly the circumference. I will not die, I will not have an accident, and I will not lose much if my circumference is plus minus 1 centimeter or 1 inch. But if I send a satellite to space and I don't deal with floating point operations to the, I don't know, hundredth of decimals, I may kill a $10 million satellite because of that little mistakes. And that's where these people, they use GPUs and they use CPUs, and why they insist on floating point operations capacity for that kind of complexity and level of precisions. Does that make human sense? Or anyone who can put it in layman terms, you're welcome.
Can someone break that down to make that simpler?
Yes.
Yeah, I would love clarification on how many, is there an approximate rule of thumb on number of decimal places is considered tops versus like flops? Obviously 100 decimal points is massive, but can you do you have 1.33 on there, and that's pretty common in statistical calculation. So is 1.33 even with just 2 decimal points considered floating
No,
points?
this is just the human example for us to crystallize it. This is what we would do at the human level when we go with decimals. We go up to 2 decimals and then it's too much. But in calculations, and depending if you're dealing with NASA-like data, or you're dealing with genetic calculations of combinations and stuff, some models and some hardware, they may go 1,000 decimals down the road because they cannot afford to stop too early and round. So the rounding becomes a problem in these advanced mathematical models. You don't want to round too early.
Yeah, it makes sense.
Yeah, that makes
Thank
sense.
you.
Yeah, get that.
So that's for T-flops. But
yeah, so
yeah.
I was gonna say in my mind, you know, just layman terms, because at the end of the day, this GPUs, they're just doing a bunch of matrix multiplication.
Yes.
Let's ask ourselves, how many of you guys can do like solve an equation, you know, 2 equations, 2 unknowns, 2 by 2, and do 3 by 3 or a million by million, right? And solve that matrix, right? You're doing the matrix multiplications, then you have decimals. I never liked decimals or fractions in school doing arithmetic. So the more what do you call it, operations. So if you're using like 100 tops, for instance, right, to basically train an AI model, so that's a top is 1 trillion operations, you know.
Yeah.
Literally in I don't know, Mohammed, keep me honest, is that in a second or
it's in a second? So
it's in a
yes,
second.
and
That's
you
a
raise a
lot.
good point. So you know, when we use ChatGPT and when we use Llama 3.2 and we query with chat and we do inference, usually the model will use TOPS calculations because they don't have to give us very precise answers. They have to just give us semantic answers, full words, full numbers. So when you're inferring, when you're using an AI model, you want to have more TOPS to get faster answers from the AI model. That's how it translates in the use of the AI model. Now, if I want to fine-tune an AI model or train an AI model on advanced calculation, advanced steps, advanced transformation, I want more T-flops because I want more hardware and software capacity to do complex calculations and complex multi-step processing. So that's where, so I'm always coming back, Mog, to our objective is which hardware should we buy, which hardware should we use, for what is our use case. That's where I'm trying to always gear it towards that kind of decision making.
Got it.
So that's for the tera trillions of operations, and it's fantastic because this is way beyond the human capacity, and it's just going bigger and bigger. And sometimes you have to combine both in your business use case. A company may want to use inference 50% of the time, but 50% of the time they may need more T-flops because they have the intention to train a model or to do some more advanced calculations. So I hope it's enough. We can come back to it. Let's now talk about the other two hardware common features. One is CUDA cores, and CUDA stands for Compute Unified Device Architecture. It's a hardware, it's an electronic hardware setup that allow computers to do parallel calculations. For example, the CPUs, they use like more sequential calculations. But GPUs, because they deal with graphics and multiple types of data, like you said, Mog, they need to run multiple matrices at the same time of different formulas. So the CUDA cores is the underlying physical architecture that multiplies the number of brains. I try to give an image. It will split the big brain of the AI, the big processing power of the GPU into like cores, smaller cores. But now we have 1,000 cores instead of one single core. I've split it in 1,000 cores, and each core is processing one operation in parallel. Now I can process 1,000 parallel computations because I have 1,000 cores of CUDA. Does it make a bit of sense? It's not so much about just the power. It's about breaking down into smaller cores so that we can do more and more and more multiplications with the same single volume of CUDA, initial single volume of CUDA. So that is the CUDA, and that is why it's important. for enhancing parallel computation. And then you have another one which is called the tensor cores, which is another kind of cores. So every time you see cores, that means dividing a hardware or a software into smaller bits so that we can use those smaller bits at the same time multiple times. So tensor cores is a specialized hardware to do mixed precision matrix operations. So mixed precision is that, like I was saying, sometimes if it's just an answer, like we ask a question to ChatGPT, come back, that's called low precision answer. It's an inference, it's a low precision. But if I ask now ChatGPT to say calculate for me pi to the 100th, that becomes a medium precision. If I say calculate the orbit of this star around this in 100 years, then we go to like much deeper precision. And I will show you how we qualify precisions, FP32, FP16, and so on. They have some norms about that, but that's what it means. It's the level of precision of how much deep in that semantic or that number you want to go in terms of floating digits or decimals or precision levels. Granularity. I think the generic word is how granular do you want to be in the answer of the AI. That will be the tensor cores. They will help you to do mixed operations. Very granular, not so granular, mixed level of granularity. Sorry for the more English, but that's about the main terms. There are other terms, we can cover them as we go, but I thought these are the most important, and some of them are not very well known, or sometimes we think we know them, but we don't really understand them, and sometimes we make the wrong, we buy the wrong graphic card for our purpose, basically. Guys, anything you want to add? Any questions before I show the Google Sheet? We will see this in the Google Sheet as well. Are we good?
Yes.
Excellent. Let's move to the Google Sheet. So I want to share with you a few things that we updated. Okay. So in our first session, we already shared with you guys all the types of, sorry, I'm going to just delete some stuff that I left here. Don't need this anymore. Okay. We did this in the first video, that you can come around and organize the matrix of all the possible GPUs depending on what do you want. Do you want more gigabyte of RAM and you start for the smallest, or from the biggest because you have a specific application that needs a lot of GPU RAM? This is how you classify, and then you want to see which one gives me the highest number of gigabyte of RAM in one core, and then maybe I want to know the price for that. So the price is here. No, sorry. The launch price is here. So here I can get 40 gigabytes of VRAM in one graphic card for $10,000. But if I want to have 48 with this one, it's going to cost me $6,000. Yeah. So you can find. Sorry, I messed them up. $4,500 for 48 gigabytes. That's quite a good. Is the first lowest price for the highest RAM. How do you call this, Eli? Is it like the best price ratio?
I'm slang, best bang for your buck.
Yes. So this matrix allows you to find the best bang for your buck.
That's right. That's
yes. The best bang for your buck for that particular parameter that you are interested in. So now if, let's say, you are very careful about electric consumption, then you organize by consumption in watts, and then you see which lower wattage can give me the highest, I don't know, GPU RAM. And now you can see that, hey, I can have here, this is the best. I can get 32 gigabytes of RAM while consuming only 60 watts. 60 watts is nothing. A small solar panel will be able to run this without too much energy. So this is what we've done, and we added many columns that I want to present to you what we added today. So we added all these columns here. I'm going to highlight them. All the T-flops and tops and sparsity, all this was added. And this is what we have defined just earlier. And now we can classify our hardware according to those parameters that we defined. Then we added also, we used to have only the launch price, but we noticed that the launch price of a graphic card is not really representative of the accounting term is when you put all the costs together and you get like the landing cost. How much actually it's going to cost me to have this, because I may need to buy another hardware with the graphic card. I may need to buy a computer, a PSU, a power supply unit. So we added, this is just the card alone, and then we added another column that we call the price for plug and play. Like if I have this card, and this card, for example, if I take the RTX 3060 here, I was saying that the RTX 3060 is one of the cheapest price for getting 12 gigabytes of RAM, but actually that's not the final price, because you either need to have a computer to put it inside, or you need to be able to have an eGPU casing to put the graphic card in the eGPU casing, and then plug the eGPU casing to your USB-C port. Now you don't need to buy a computer, you just buy the eGPU. So that's what we mean by plug and play. What kind of hardware can I add to this card to make it plug and play and use it on my existing computer? So here we just added $150, which is the price on Amazon for getting an eGPU. But that's what will allow you to have the 3060 to work plug and play if you don't want to buy a computer for it. Now, if let's say you say, no, I want the full set, which is this new S column. I don't have a computer ready to accept these big graphic cards. How much should I inform my client, or how much should I invest to get the whole set with the graphic card inside? So that's where we added the CPU, the graphic card, the RAM, the power supply, the fans, everything except the keyboard, the mouse, and the display. This is what you need to have a full set that can run now your AI model and on your operating system. So it will cost you about $1,000 to have a PC, desktop PC that has a 360 inside. So now we can tell to our companies that yes, the graphic card alone is this price, but if you don't have any PC to accommodate it, then this is the budget that you need to put into your accounting. So that's for the full set. Sorry, I'm going to do a quick drink.
Mohammed, could you quickly just describe, because there's some people that weren't here last time, regarding what the colors represent. And before you do, you can highlight the whole row just by going to the row number to the left, and it will highlight, making it easier for everyone to see.
Like this?
Yeah.
Yes.
And now the whole row's lit up.
Yes, cool. Thank you, Eli. So I made it a bit bigger. So thank you, Eli. For those who were not here or didn't watch the first one, the color code, and I'm sorry, I'm colorblind, so I don't know which one is which. I think this one I know is green. So green, it means that in that column, in that type of feature, green is the top in the market, the top value in the market. So if, for example, if I organize my RAM by the biggest number of RAM per single GPU, the idea is that this should be green as well. Sorry, here I'm going to correct this. So all the cards that have more than 24 gigabytes of RAM are considered high-end cards because they are more rare in the market and much more expensive. So when you have the green, that means that it's like the top of that kind of category. And usually the price will increase steeply when you need to go to the green. Because you see here, if you get, you can get a cheap card that has 24 gigabytes, like the 3090. It will maybe cost you only $600. Sorry, $1,500. But to move to 32 gigabyte here, it will jump to $8,000, like 6 times more expensive. You see, that's the difference between orange and green. There's a suddenly sharp. So green is the top of the top. Orange is like medium range that is already professional level. Green will be like data center level. So maybe I can put it this way, Eli. Green is top market level, like almost data center level. You can run a data center. Orange you can run it in a professional environment. You can really do for a big company or like architect companies that do a lot of 2D, 3D design, video editing companies. They will be in this orange area because 24 gigabytes of RAM is enough for them to do video 2D, 3D processing. Yeah. And then you have the light orange, which is like what I call the prosumer, professional consumer. It's a consumer like us, Eli, that are versed into the tech, and I want the best level of the consumer price or the consumer category. I would go for this, at least for this level here. Yeah. And then when it doesn't have a color, it means it's either entry market level or entry level of performance. Does it make sense?
Yeah, it does. Anybody got any questions?
Yeah,
Because
so
this is quite powerful. This will save you a huge amount of time visually. I've never seen anyone else do this when it comes to hardware. So we're very lucky.
Yes, it helps visually to quickly. So the idea is that when I do my research and I highlight my line, I want to see as much color as possible in one line so that I know that what I'm going to choose here is checking the best boxes in many places. Yeah. So let me simulate how I would choose a card for personal use as an example. So I would go first, I would say, wait, the first decision-making parameter is my budget, how much I'm going to put in that card. I want to put less than $500. So I'm going to go to the launch price here, and I'm going to organize by small to big. So I'm going to start at 99. 99, I can get a Jetson Nano, but it cannot do much, you know? It's very white, not much processing power because this is more for edge applications. Then I start to have, I want to see when do I get more color before a sharp price increase. So if I look here, the rows, and I look to the left, I start to have some colors here in two of the most important parameters, which are the RAM. Yeah, so I start to look where is the colors starting to appear. This is the first among the cheap ones to have 12 gigabyte. It even has more gigabytes of RAM than the next 1, 2, 3, 4, 5, 6, 7 candidates, which are more expensive. That's a good bang for the buck. Yeah. So what is this? 3060? Let me see. Oh, I'm getting a good score in terms of what? I'm getting a, okay, here it's not so good, but here I'm getting some orange. That means I have some good performance parallel computing. I have good tops. These are the tops. FP16. Sorry, these are the tops here. I have 100 tops. It's not bad. We haven't colored the tops yet. We will color them for you. But 100 tops is quite good. I get sparsity, 1.8 coefficient, which is quite good. And the price for $329. So this is a first sweet spot. My next sweet spot is here. I get either I go for 16 gigabyte or I go for 12 gigabyte, but faster memory. And also here you see, I get faster memory, but also I score better in this. I score better in efficiency of energy. I score better here. You see, I start to have a lot of colors here. How much? $600. That's the next sweet spot for about $500, $600. And then you continue. Depending on your budget, you're going to find the best card that can give you the best performance that you're looking for. Does it make sense a bit?
Yeah. Definitely.
Okay, Eli, thank you. So this is what we've added, and we can interact about all this data. But let me show you also, so I covered the columns. We added all these columns, but we also added new rows. So in December, is it Jason Huang, the CEO of NVIDIA? He presented the new Jetson Nano Super. Yeah. And at that time, when we did this in December, I was telling you that Jetson Nano, they are nice, but we only studied the Jetson Nano, which doesn't give you much power to run a model locally. So what we've done now is that we covered all the models of NVIDIA, all the small models of Jetson. So let's look at the Jetson family. Here are all of them. Yeah. Now we can actually consider advise maybe our clients or ourselves for a specific use case, why would you go for a Jetson and why you should not go for a Jetson. Because sometimes some clients say, hey, I saw the advertisement from NVIDIA, this is super good. Yes, but for what? And that's what we need to understand in this graphic. So let's look first at the Jetson Nano, the Jetson regular Nano. It only has 4 GB of RAM, which is, I would say, the lowest amount of RAM that you want to purchase. Don't purchase less than that. Actually, even avoid purchasing 4 GB of RAM because you will only be able to run very small models. Preferably, go for 8 GB of RAM or 12 if you can. But that's where the Jetson Nano is. And the Jetson Nano was designed to be embedded on a robot, on a camera. So it's not embedded as a computer system. It's called for edge application on the edge of another hardware, be it a robotic arm or a camera. And you have a camera and you want to add a feature of facial recognition to the camera. That's where you will put the Jetson Nano, so that Jetson Nano can take the influx of the images, treat them, and then give the data back to the camera. That's what it was designed for. But then they launched this one, Jetson Nano Super. And here it starts to be interesting because it's a faster RAM. It has 8 GB of RAM. It uses very little power, 25 watt. It's a very good efficiency of use of energy for computational power. It's almost the best. It only consumes 1.5 watt per teraflop. And then it has quite good performance here. If you see the T-flops in FP16, this is what is used to fine-tune models. We can fine-tune some small models. It has a good performance. And here are the tops. And the tops, it's not bad. So if you compare the tops, so we said that the tops are the tera operations per second for full numbers. The Jetson Nano is almost useless when it comes to tops. It's not able to do a lot of performance for tops level. So it will not be able to run a model like Llama 3.2 and give us answers. But 67 is a reasonable number of tops to install Llama 3.2 and chat with Llama 3.2 and get satisfactory, fast enough answers from Llama 3.2. That's what it means here. If I can get 60 tops, 100 tops, I know that on this device, I'm going to install Llama 3.2 and I can query it and get answers pretty fast. So you see these three models are viable to install Llama 3.2 on them, and they still very small factor. They're like this size and they consume very little power. But what is good with the Nano Super is that it has enough tops. It uses the full maximum performance increase ratio of the sparsity. It is able to fully remove the zeros. So for example, here, this card doesn't fully remove the zeros. That's why it will only increase the performance ratio but 1.8, which is not bad. That means it almost doubles the computational power. But when you see 2, that means that this hardware is able to fully utilize the sparsity feature. That's why it's able to double the computational performance, because it removes the dealing with the zeros. It has 1000 CUDAs. So you remember the CUDAs are the cores, the number of brains to do multiple operations at the same time in smaller brains. So 1000 CUDAs, that starts to be interesting. The normal Jetson Nano, only 128 CUDA. You can only do 128 operations at the same time. But here you have 1000 cores. So that increases a lot of things. It has also 32 tensor cores. The normal Jetson Nano didn't have any cores actually, because it's a different architecture. But the most important here is that among all the other candidates, it's $249. So for $249, it packs enough CUDA, enough TOPS, enough T-flops, enough RAM for me to run quite medium-large models of Llama 3.2 on this small little box. But not only that, if you look at the column plug and play and the full set, it's actually a computer in itself, because if I can plug the Nano through the network, plug it to my Wi-Fi, and then with my laptop I can use Llama 3.2 that is hosted inside the Jetson Nano Super. So that's how I can plug and play through the network. But I can add an SSD drive, an NVMe SSD drive into the Nano, and use it as my AI computer, as my AI server. So now I have a full machine for $349 or $400. I have a full machine that can run all my AI, my Windows or my Linux, and Artilla, and all my Artilla bots, everything in one small device. I just need to put a computer display, keyboard and mouse, and I have a full set to work with my AI things. So that's what I wanted to highlight with you guys. We have a very nice new candidate, especially for inference. If let's say you have a company that is an insurance company, they have, let's say, 10, 20 employees, and they want to offer chat with my data, chat with my documents, but they don't want to use ChatGPT because they have private documents, private contracts with their clients. I can tell them, no problem, you don't want to invest in a full computer. How about a Jetson Orin Nano Super? I will install everything for you. I will develop some Artilla bots that will do X and Y, and you can either use it as a computer or share it in your network, and people access through the local network and turn it into a server. And the hardware is only $349, and my services is $750. So for $1,000, I enable you with local chat that is completely private. Is this a good speech? A good sales speech, Eli?
Tell me about it. You've already sold me twice.
Yes. So I'm selling my services, but it's worth it because I bring to you a hardware that is going to give you a lot of value for very little money. And remember, it only consumes 25 watt per hour, or let's say even 50 watt per hour. It's nothing. It's like a bulb of light. So I'm giving you an AI powered computer that consumes as much as the light that is above your head. So for those who have CSR and green policy and so on. Okay, so that's what we've added, guys. There's also more powerful Jetson machines, but the prices, they go up. So you have, for example, this one, the Xavier 16 gigabyte. You even have the Jetson AGX Orin 32 gigabyte. That's huge, a lot of RAM. But you see here, if you take this one, the costs go to $2,000. So maybe you want to think, wait, for $2,000, how many CUDAs can I get? Is there another card, another setup that can give me more CUDA because my client or my application needs more CUDA? Or you say, no, CUDA is not what I need more T-flops here. Yeah? Can I get more than 100 T-flops? Is there something that for the same price can give me more T-flops? So that's a little bit the idea of this matrix. And please don't be daunted. Just go to it and start, make a copy of it. Like you go here, file, make a copy, and then you can add your own colors, your own choices, and then you highlight, and you can highlight what you want to buy, what you don't want to buy, or you can plan your purchase and multiply it. Now, this is about the graphic card. We also added last time, Eli, at the end of our video, we said that a power supply unit are very important because these things consume a lot of power, especially when you go to workstation professional level. So we added this tab for what kind of power supply, at which price, how many years of warranty, the sizes and all the connectivity, and is it for data center, workstation, or consumer level. So this will allow you to, so this is one of the most important elements in the hardware. You can buy second-hand cards, second-hand fans, second-hand CPU, but for the power supply unit, please don't buy a second-hand because it could kill all your expensive hardware. The other hardwares, when they fail, they don't impact the other organs. But when the power supply fails, it can electrocute all the other expensive elements, if that's proper English. So I'm done with my download of data, and let's open up the floor for more interactions. And if you guys agree, it will be, I think, at least for me, interesting to see what kind of use cases do you have in mind for you or your clients, and then let's discuss how we would go about it in terms of AI hardware to choose. So guys, please don't be shy, and let's give it a try. And Eli, if you can help me because I don't see the chats and I don't see the hands.
Yeah, I guess I have one question.
Yes, Kyle, please.
Yeah, so like how does it so for example, if you buy Jetson Nano Super or a 3060 or a 4070, how does it differ in terms of using it with Llama? Like, what
Oh,
is like the
that's a very good
thing you
question.
can see? Yeah.
Yes. So how do you want to use Llama? Do you want to fine-tune Llama 3.2 into your own fine-tuned model, or do you just want to use Llama and get answers for an application?
Yeah, I guess just answers
Just answers. So that's
for now. And
inference, yeah?
yeah.
So when we said inference, then you want to have more tops, as much tops as you can. So the more you have tops, the faster you will get answers from the AI. So let's classify by tops and look at the price. So where is the tops column? Here, INT8 tops, that's the measure we use. So let's classify here by Z to A. So of course, this is like data center level. These are monster cards. They process a lot of tops, but then the price is $50,000, this card. So yes, it has the biggest tops here, but it's $50,000. So let's look at the price here. Let's see when there is a dip in price that gives me a lot of tops. So you see here, there is a sweet spot, 1,799. I get 1,500 tops. Actually, these two are good. These two are the RTX 4090, which is a consumer card, but surprisingly, it's very good for processing Llama 3.2 answers very fast and very efficiently. So you see, that's the sweet spot. After that, it's more expensive, more expensive. Here is a second sweet spot. What is this? This is the RTX 4090, again, the consumer card. So let's look at the next one. Maybe this is still out of budget. So 30,000, 1,200. Let's go and see what is the first option below 1,000 here. Below 1,000, I get 238 tops. That's the nano supreme. So the nano super has 67 tops. So I have 240 tops, almost 4 times more tops. So what is this model? RTX 3080. RTX 3080 will give me the highest number of tops to run Llama 3.2 for sub $1,000, less than $1,000. I can also get 799, but actually I have less tops. I have 230 tops. That's the 4070 Ti. So I better go with the RTX 3080. See? So let's look further. If I go here, let's look at really the cheapest deal I can get for the most tops. 599, 499. 499, what is that? RTX 3070. Good. 399. What do we have at 399? Sorry, I lost my mouse. Come on, mouse. My mouse needs some tops. Here. 399, the 4060. 399, the 3060 Ti. It has 152 tops, which is quite good. Quite good. So here there is a problem. 570 should be on the top. But I can go cheaper a bit. I can go 329. 329, that's the 3060. That's again, my favorite card. So the 3060, to answer you, will give you twice more tops than the Nano Super, than the Jetson Nano Super. So it gives you two things here, Kyle. It gives you twice the number of tops, but also it gives you 50% more GPU RAM because the Nano Super has 8 GB of RAM. The 3060 has 12. I can load bigger models and they can run twice faster. But I sacrifice the form factor because the 3060 I have to put it on a desktop or an eGPU. It's massive. It consumes more electricity. So is it better for me to go with the Jetson Super Nano because of the other parameters? Yet I am still satisfied with the 67 tops, which is still reasonable to get Llama 3.2 to work. So that will be your last decision-making ping pong or choice question. Does it make sense?
Yeah, it does. So if it has like twice the amount of tops, then does it mean like it will approximately generate 2 times as faster answers?
Exactly. It will be exactly it will generate the same answer twice faster.
Oh, twice as faster. Okay.
Yeah.
Okay. And the RAM basically means I guess the it can run like larger models. So for example, like if you compare it to GPT, you can like for example, the mini can only the other one can only put in like a GPT mini, but this can like do a larger model like
Exactly,
4.0.
it's the same
Something like
equivalent.
that. Yeah.
Yeah, so let's say the Super Nano, you can load Llama 3.2 3 billion parameter, which is about 3 gigabyte file. It will fit inside the Nano RAM. But in the Nano Super, the Jetson Nano Super, you cannot fit the Llama 3.2 vision model because it's 11 billion parameter. That would require 10 gigabyte, but you only have 8. But the RTX 3060 has 12 gigabyte of RAM. Now I can use the vision model, which means I can do AI computer vision. My AI can now generate images or read images, which if I do it with the Super Nano, it will still generate images and read images, but it will be 2 times, maybe 3 times slower because of the RAM and the TOPS. So if you're not gonna deal with computer vision, then you will not feel much loss by going with the Nano. But if you intend to do image processing and things like that using the AI, then it's worth to go for the 3060. It will be a big difference.
Yeah,
so these are the questions that you need to ask your clients when they ask you, is that what is the ultimate aim? What is the 80% use case, not the 20% use case? What are your team going to do every day, most of the time 80%? Let's choose the hardware for that first. And then maybe 20% of the time they do video editing or something. Then we can look at either renting power or, I don't know, finding another way. But usually you want to cover the 80% use case first, or at least identify it. A second thing, Kyle, for you to know is that you can scale. You can plan your scale. So if, let's say, you can put 1 Nano Super, and next month you buy 2 Nano Supers, and Llama has a load balancing mechanism that can aggregate 2 small Nano. It can aggregate 8 gigabyte of 2 nanos that are physically distinct. It will put them together into one virtual GPU instance. So if you put 2 nano together, then you can start to do also computer vision, and you can host the model. It will split the model between the 2 Jetson Nanos. So 2 Jetson Nanos, and the 2 of them cost, let's say, $300 each. That's $600. Hey, wait. Now $600, I get 16 gigabytes of RAM, and I get 67 by 2, 130 TOPS, which is like a 3060. So now it's reverse. I get the same TOPS as the 3060, but I get 50% more RAM than the 3060, and I can still split the load between these 2 nanos.
Yeah, and you also mentioned that there was like the general purpose of getting fast answers, and you also mentioned fine tuning.
Yes.
So what do you mean by fine tuning? Do you mean like custom training, like with your own data?
Exactly. Yeah. So fine tuning, you need more T-flops. So if you're planning to use fine tuning, you need to look at FP16 T-flops. That is the most important parameter for fine tuning a model. So let's look at that. Let's organize by more T-flops to less T-flops for the price. So these are the giant cards, but the prices are huge. You see 50,000 in the $1,000. Let's go sub $1,000 for maximum of T-flops. So actually, let's look at T-flops multiplied by sparsity, because sparsity will give us the maximum output. So this column, FP16 T-flops multiplied by sparsity. So let's see, when does the price dip? So here, 2,000, 1,000, 699. It dips, but I'm still high in the T-flops. I get 200 T-flops with sparsity for $600, and I get for $499, I get also 100. So actually these two are good. This one is even better, $399. What is this? Jetson Orin NX 8 gigabyte. Oh, that's sweet. With this one, I can do better fine tuning for the buck, for my money. Yeah, I can even then put 2 of them, or I can go for this one, has 16. So this one is even better because I double the RAM. You see, I double the RAM for an extra $100. That's worth it. If I double my RAM for extra $100, I would go for this guy. This guy is the Jetson Orin NX 16 GB. I could go for the AGX Orin 32 GB, but look at the price tag. The price tag is $2,000. I can achieve similar output for fine tuning for half the price. So I would go for this personally, for fine tuning. The next sweet spot may be far down. Here, 399. 399, who gives me that? The 4060 Ti. And then you can go on. So this we already got, so 299. 249, what is that? 249 is the RTX 4060, 4050. These are your next best deals, and that's it. After that, it's more expensive or low capacity. So I think you can settle on this one. This one is really good. And like Eli was saying, for that particular objective, maybe you want to put here, you add a comment. I forgot how to comment here. Best for fine tuning at low price. That is what I will go for this specific use case. And I save it for me to remember this. Does it answer your question?
Yeah. Thank you.
Excellent.
So yeah, so for fine tuning, I guess Jetson Orin might be a good choice, and for like general purpose, like for both fine tuning and
yeah, you're right.
That,
it plays
maybe 3060 might be a good choice.
Sorry. This one is good. This one is not bad. The Jetson Orin for a little bit of both, but you have a difference. Let's compare it to a 3060. So let's highlight the Jetson here. Let's highlight it with I don't know, this one, this color, and then let's highlight the 3060 just to compare it. Where are you, 3060? Here. So I don't know how to put two rows together, but let's do some gymnastic. I think I can hide some rows here. Yeah, I think I can hide some rows. If somebody is familiar, please let me know if we can hide rows.
Yeah. I can see hide rows there.
Where is it?
It's at the top. Yeah, there. At the bottom.
Oh, here. Cool.
Yeah.
Excellent. So that's a good way. Okay, let's compare these two guys. So let's look at, so there is a big difference in terms of electricity consumption, depending on how much energy you want to put. That there is a major difference, 25 to 170. Then there is the precision T-flops, which is very important for fine-tuning AI models for scientific calculations and high precision level. You see here the Jetson is outperforming the RTX 3060 by a measure of 15 times better. So that's you have to pay attention to this. This is medium precision. The mixed precision that we were talking about, T-flops, it's also almost 8 times better. Here it's 8 times better, 10 times better, 10 times better. Here sensibly the same. But this is where we are hurt, is that I don't have as many CUDAs. And that's the main difference, where the 3060 is 3 times better. But beyond this parameter, everything else, the Jetson Orin, is between 5 and 10 times better. So then you will study how much does the CUDA difference impact my fine-tuning model, depending on the type of data set I have and the type of model that I'm going to fine-tune. You can like Google it and even ask ChatGPT, and it will tell you that maybe CUDA is not as significant as the T-flops. The T-flops gain that you get are much more important. You will be able to fine-tune the model. So what I do, Kyle, is that I go to ChatGPT and I tell it, if I have this hardware and I have this kind of data set, I have 1,000 rows of data set, and I want to train a model that recognizes people on images, estimate how many hours of computing I need to fine-tune this model, and it will tell you 100 hours, 200 hours, and then I say, okay, good, now give me if I do it with the 3060, and I say, oh, 1,000 hours. so then I will make my decision based on how many hundreds or thousands of dozens of hours, I will need to fine-tune my model if I choose this hardware or this hardware. We can cover that in another session on calculating the fine-tuning computer time, because for example for us, we say AI automation on premises. Imagine a bank tell us, hey guys, I want you to come into my bunker, data bunker. No data can go out. Bring your powerful AI server. We have 2 million customer files, and we need this operation, and we need to fine-tune a model that will take all our data, and it has to stay running in our bank. How long do we need to run this in our and keep it in our bank? Is it 100 hours or 1,000 hours? So we need to be able to answer. I need to come to your bank, set it up, and let it run for 12 hours or 50 hours or 1,000 hours, or maybe it's not worth to do it. Maybe I can advise you to buy this and this and that and run it locally because this is going to take too long, you know? So that's where you need to understand the hardware. So fine-tuning, we can cover it more in maybe a third hardware. We can do a third hardware session that is specialized on fine-tuning because it really has its own parameters and its own considerations, like ECC RAM or non-ECC RAM. You know, so we can dive a little bit more on that on a separate session.
Yeah.
Guys, please don't be shy.
Yeah, I have one more question if nobody has any.
Yeah, of course, please.
Yeah. So I mean, many people use also Mac for their operations.
Yes.
Mac OS. And I mean, I don't know if any research was done on this, but like
no, let's do it
I know
now.
that the new chips, like the Mac's new chips, like M4.
Yeah. So let's take a model. Tell me a model of a MacBook or MacBook Pro, or whichever model of Mac you want to use, and we're gonna get the T-flops and let's compare it.
Yeah, so like there's like M4 and M4 Pro, M4 Max.
M4 Pro, do you have any reference, like how many, the processor size or something?
I mean, it's like CPU, GPU all in one. So I mean that's the model M4 Pro.
But is there like a reference like 5 gigahertz or 3.5 gigahertz? Do you see anything, please? So let's see, or let's take the most expensive Mac.
Yeah.
M4 Pro and M4 Max. Okay, let's see one of them. It's not here. Let's just take let's just use M4 Max. It must be expensive.
Yeah.
So let's do that. Give me the data values for Mac for the following parameters in the context of AI fine-tuning. And then I'm going to give ChatGPT all our parameters here. So let's just give it this FP16 T-flops, TOPS, and CUDA, and see. ENT8 TOPS, CUDA cores, and Tensor cores. And gigabyte of VRAM. Yeah, let's see what is it available with the M4 Max. So 40 cores. So let's do this. Let's add it now. I come here. Let's add here Mac. Sorry, let's move this a little bit smaller. Eli, are we getting overtime?
Well, it's an hour and a half. It's traditional for you to be overtime.
Yeah, but the questions are very good, and I think this is quite good. We didn't cover it. So let's see here. What do we have? We have 40 cores, FP16 performance. So it's not telling us here. TOPS. 38 TOPS. Yeah. So 38 TOPS. Let's put that in the TOPS here. This one, 38 TOPS. Okay, what's next? It gives us Tensor Core. He didn't give us the equivalent, but it says that GPU RAM up to, that's the speed, up to 128 gigabytes of RAM. So that's a lot. So maybe we can put 128. That's a lot. And tensor cores, it has 16 tensor cores. So let's put that as well here. Tensor cores, 16. What else? We have CUDA cores. CUDA cores, it didn't tell us. So equivalent of CUDA cores. How many equivalent CUDA cores would it relate to for same power under NVIDIA GPUs architecture? Let's just get an estimation. $16,000 CUDA. So let's take that. So it's equivalent to an RTX 4090. 16,000 CUDA. Okay, I think we have enough to compare. So what I'm not sure is the gigabyte, because I think this is the very high-end model. So let's ask what is the price launch for the fully featured M4 Max model that has 128 gigabytes of VRAM. Let's get the launch price. $4,000. Okay, I think we have enough parameters, right? Here, $4,000. Okay, let's compare now. So we have the M4. Now we want to put in highlight blue. You want to compare it with which setup or which card?
I guess like a similar performance.
Like compared to something that is $4,000 in using another setup? So actually,
yeah,
actually $4,000 is the full set.
Yeah.
So let's compare it to what can we get for $4,000 with another setup? $4,000. Maybe something like this. Yes, the price I think went down a little bit. So let's compare it to the L40, just to see. So if I do in between these, hide rows, unhide rows, sorry. Where is the L40? We're getting there. And now I can hide rows. Okay, cool. So we want to compare these two. They are similarly same price, yeah? So Tensor Core, the L40 has a lot more Tensor Core than the Mac. So depending on what you want to do, it has also a little bit more CUDA. It has a lot, there is a huge difference in the TOPS. This has 38 TOPS, this will give you 1,300 TOPS. And the major difference is that the Mac has much more RAM. It can load much bigger models. And it's probably faster RAM. So I don't know if this is enough. Maybe we need to collect more information, or maybe we can play around with other cheaper versions of Mac. But I would say CUDA TOPS. You see, it has less TOPS than the Nano Super, which is weird. So I'm not sure if we have a mistake or if it's really not so good at inference. We will need to do more research, but this is the initial. I like the huge amount of RAM because to get this level of RAM, it will be $50,000. You see, these things are $50,000 to get those big cards. So this alone may be a buying point for me. If I want to load gigantic models like Llama 3.3, Llama 3.3 is 70 gigabytes. It will not fit in my normal cards, but it will fit into the Mac. Does it answer partially, at least for now?
Yeah, for sure. Yeah, I was just curious about how it works with that. I think it uses like a different architecture. Like
exactly.
It's like
That's why it's hard. Yeah. So I think until we got this new Macs, Mac was out of the picture. Yeah. Because Mac was not very good in parallel computation for graphic and AI models. But now it seems that they're catching up. Probably this model is already a good deal. So we will add few Mac models for you guys. Few MacBook Pros, few laptops, and few desktops from Mac, just to see where we are. Yeah?
Yeah.
Cool. That's a good question. I think, any other question, Kyle?
Oh yeah, that's all for me.
Cool. Thank you. Anyone, please don't be shy. We can either take a couple of minutes, or Eli, maybe some people need to go to lunch, and some people like in the eastern side like me want to catch some sleep. But I hope first this was useful. I hope that it demystified a little bit the hardware about AI, and that you guys will be able to better advise your own purchase or your client's purchase and needs according to the use case. And this is a work that is alive. We will be updating this sheet as we go. Some of us can update it, not only me. So it will grow as we go. So as usual, Eli, the fine words are with you. If there is anything that we can attend to.
I just want to say thank you regarding the hardware, because if we don't get the hardware right, then everything else is just going to be wrong regarding of the software. Also, don't forget about the power unit. That essential for keeping things stable. You know, when you're always trying to work out which is the best unit, try and match it as closely to the total power that's being used on that CPU and the board. That keeps things stable if you keep the power unit as close to what's being totally used on the board. That's essential. As he was saying, it's the heart of the system. So let's say that the wattage is 500 watts being used on the board, the CPU and etc. Then try to get a power unit that's close. Don't try to overdo it and get double the power unit.
It's a very good point, Eli. So let me write this down. You need to go plus 30%.
Yeah.
You need to go plus 30% than the total consumption that you have, because there is efficiency loss, and there are peak consumptions of certain hardware. So you always need the bandwidth that when your hardware will peak and the performance go down, and your system heats up with heat, the performance will go down. Especially when you're doing fine tuning. If you're doing fine tuning and it's taking 100 hours, the computer is running, the temperature is going to go high. At the 80s, 50s, 60s hours, the performance will start to go down, electricity consumption goes up, and that's where it can break if you don't have this buffer. So usually the buffer, depending on your level of application, if it's consumer level, prosumer level like us, 30%, 25% extra is good. But if you are in a data center, you need extra 50% of power supply, and you need a second power supply as a backup in case the first one dies. So you need power supply redundancy when you work at the data center or professional level. So we can also cover this, as we go, guys. We can evolve into hardware for fine tuning, hardware for data centers, hardware for companies that have their own data warehouse in their office. Many companies have a small data center with few racks of servers. They already installed air conditioning, networking. They invested sometimes few $100,000. How can we help those companies with all this new hardware that comes in and understanding the power supply strategies and challenges that they may have?
A quick follow-up question: is that the same thing with the GPU? Like how much over the model should we be buying for?
Yes. So you take the wattage of the GPU, the wattage, And also how many cards. So sometimes you have multiple cards in one computer. So if let's say you have 4 L40 inside the server, and each L40 consumes 300 watts, that's 1,200 watts taken just by the 4 graphic cards. So that's 1,300 watts, and then the CPU is going to take another 250 watt, that's 1,550. Then the memory will take 50, that's 1,600. Then the motherboard will take another 100, that's 1,700. Then the fans and the stuff, they will take another 200, that's 1,008. And then I'm forgetting something, the hard disk is going to take another 200. We're already 2 kilowatts, 2,000 watts. And CPU, processor, RAM, and the network card and all these things, you add another 250. That's already 2,250 watts, the total system consumption, including the cards. So if you have 2,250 watts for this setup, this is a powerful setup, you need at least a 3 kilowatt PSU. A 3 kilowatt PSU costs a lot of money, probably around $1,000 or $800. So that's how you calculate.
And
if it's a small PC, you only have one 4090. The 4090 consumes 170 watt. Then the CPU, motherboard, and everything else is going to consume another 300 watt. You can run the whole setup with the 4090 with the 750 watt PSU. That's safe.
And then separate from the power, how much overage on the RAM do you recommend versus the model size?
Oh, how much virtual RAM? Not the GPU RAM, the CPU virtual RAM.
The gigabyte RAM, the column B there.
Column B here. So this is the virtual. So here you need to have plus 20%, plus 30% from the model that you want to host, because
Okay.
to run a 10 gigabyte, to run a 9 gigabyte model, I need the 12 gigabyte card, because about 30% is used for preparing the model and querying the model and just maintaining the operations. Only 10 gigabyte is made available to my model. So
Perfect,
so
thank
let's do 30%, 30% extra than the model. Good question, by the way. Anybody has any other question? And also, even if we don't have the answer, we can seek it and complement it. Are you confident you
Mohammed,
can? Yes.
it could be a good thing is when you're talking about the 30% and how safe everything's going to be, because this is paramount, is to put that information within its each section. So for instance, PSU, just put a note in there so people don't forget.
Definitely. So I'm going to do it now. Yeah. So add plus 30% on top of all components wattage.
Yeah, because it's easy to forget, and it's something that's quite essential.
No, definitely. We will add it in a way that is so we're going to add another sheet here that we will call the dashboard or the configurator. And in the configurator, what we want to do is that you can choose the use case, and then it will tell you which graphic card, which CPU, which motherboard, which model, and then how much PSU and the total cost. That will take a bit of time, and later we will see with Mog to convert it into a chatbot that can advise you on your hardware setup.
That's a great idea.
We will get into there. So here I'll put plus 30% as well. Plus 30% on top of AI model size. That's not accepting here. I'll find a way to add it. Yeah, I'll find a way to add it because I have formulas here.
Cool. Is there anybody that's got some questions before we finish off? Just stay away. Anything at all? Mohammed, you've done well.
Thank you. I hope it's not too much information, but anyway, we will share the recording, and this should provide us with enough understanding of this whole AI hardware. And soon we will understand the Jetson family, but also the Mac family, and get a full picture of what is available in the market. So I thank you guys, everyone, for your attendance and your patience. And also Eli, thank you again for helping with the session.
Pleasure as always.
Pleasure. And Mog is not here, but thank you, Mog, for all the add-ons. Thank you, Jasmine, Ryan, Kyle, for all the questions. And I hope to see you again, guys, in the next session. We will announce it soon. Are we
Thank
good,
you.
Eli?
Yeah.
Yeah, it's cool.
Superb. You guys enjoy a good evening in the US, a good night in the UK, and a good morning in the eastern side. Bye-bye,
Have a
everyone.
beautiful day. Have a
Thank you very
beautiful
Beautiful
much.
day.
day. Yes.
Take care.
Thank you, guys.
Bye.
Bye-bye.